Welcome to today's lesson. We want to discuss grade 8 mathematics under the substrand ratio. So ratio is comparison of two or more quantities of the same kind. When you are comparing two or more quantities, for example, you can be told Jane is 10 years, John is 9 years. So these two people, Jane 10 years and John 9 years. These ages can be compared as, for example, Jane's age. If you want to compare Jane's age to John's, you can talk of Jane's age, that is 10 over 9 times John's age. Or John's age can as well be compared as 9 over 10 times Jane's age. Now, sometimes you can be asked now to express ratios as a fraction. Now, for example, you have this example, you have this. If you have the two people that you have used, Jane, 10 years, and John, this side, 9 years, as a fraction, you will have Jane's age will be 10 over 9. John's age will be 9 over 10. So if you are told to express now their ages, this is fraction. If you are told to express their ages now in a ratio form, then we will take the age of Jane, which is 10, to the age of John, which is 9. So one thing we have to know that when we are expressing, for us to have a ratio, ratios are supposed to be simplified into their simplest form. For example, if this, let's say, let me pick an even number here. If this was 8, and that is now 8, let us change everything to be 8, and you are told to express them in ratio form, you can't leave it like this, 10 to ratio 8. It must be in the simplest form. So you simplify it. You look for a number that can divide both sides. So for example, 2 can divide this 4 times, and 2 can divide this 5. So this is the best answer for that. So when you are told to express their ages in ratio form, then it is ratio 5 to 4. That is Jane's age to John's age. That is expressing ratios. Now, let us look at some examples here of expressing these ratios. Maybe just an example, then we move to another thing. A basket has 6 bananas and 7 oranges. So a basket, that means it is just one basket. And this basket has 6 bananas inside it and 7 oranges. 6 bananas and 7 oranges. So question A, you are told to express the number of bananas as a fraction of the number of oranges. So question A, you are told to express the number of bananas as a fraction of the number of oranges. That will be the number of bananas over the number of oranges. So you have expressed the number of bananas as a fraction of the bananas of oranges. Number B of the same question, you can be asked, what is the ratio of the bananas to oranges? The ratio of bananas 2 oranges. So the bananas were 6, so we will bring 6 here. Oranges were 7. So that is the ratio. So the ratio of bananas to oranges becomes ratio 6 to 7. Ratio 6 to 7. Now let us look at how we can compare ratios. Comparing ratios. You are given some quantities or some ratios, and you are told to compare which one is larger than the other or which one is smaller than the other. So like there's this question here that is saying, so we are talking about comparing ratios. You want to compare ratios. Comparing ratio. For example, find out which ratio is greater. Find out which ratio is greater, this or this. We are comparing these two ratios, this and these two, to find out which one is greater than the other. So the first thing, we have to write both of them as a fraction. As a fraction. So we will have the first one here as 2 over 3. This one will be 4 over 5. 2 over 3, and this one is 4 over 5. We have to put them in fractions. Once we have the two fractions, for us to compare fractions, you need what is called a common denominator, especially if the denominators are different. You cannot compare fractions with different denominators. You need what is called a common denominator. So that common denominator is what we call the LCM of the denominators. So the LCM of 5 and 3, which in this case is what? Is the LCM. So we get the LCM of the denominators, which is 3 and 5. So this is 15. So once we have that 15 as a common denominator, then we rename both the denominators so that we have 15. So we will take the first fraction, 2 over 3, and we want to make this denominator 15. So we have to multiply it by 5 so that we can get 15 over the same number we use down here, we use up. So we will multiply the same number with the numerator to get 10. So instead of 2 over 3, we have 10 over 15. The same to this side, 4 over 5. So we want to make this 5 15. So we have to multiply it by 3. We will get 15. The same number we used down, we use up. So 4 times 3 gives us 12. This is 15. So here we have 12 over 15. Now once you have these fractions with the same denominator, now automatically comparing them becomes easier, because the bigger the denominator, the fraction with the biggest denominator, once they have the common denominator, then the fraction with the biggest denominator becomes the biggest fraction. So in that case, this is the fraction with the biggest numerator, not denominator, numerator. It has 12 and this one has 10. So this fraction is bigger than this. So once we have known that this fraction is bigger than this, now we come to the ratios. Which ratio represented this? It was 4 to 5. So that means if this question was asking, find out which is greater. So we'll come and say ratio 4 to 5 is greater than ratio 2 to 3. We have compared those two ratios. So I hope you have followed that step. You are going to compare these two ratios, this and this, to find out which one is greater than the other. Sometimes there's a second method we can use to solve this. So let us use that second method, because Sometimes you can be asked to use any of this method, or the question can be very specific, telling you to use this second method. Now, this second method says that write each fraction in form of n to ratio 1. So n to ratio 1 means the first fraction, the first ratio here was this one, 2 to ratio 3. So you have to write them kwanza as a fraction. That is what is there, 2 to ratio 3. Now, this ratio, the formula want us to, the rule want us to write n to ratio 1. Ratio 1. Ratio n to 1. Ratio n to 1. So that one is just one whole number. So that means this ratio you have been given, after putting it as a fraction, you want to make it this side 1. So you can only have that as 3 over 3 using this denominator. So that is what this rule is, that the n means that ratio you have been given to ratio 1. So ratio 1 means denominator over the denominator. Once you have that, you are told to divide both sides by 3. So if you divide this one by 3, you will get one whole, which is this. If you divide this 2 by 3, because it is this divided by this, you will get 0.6667. So you will have 0.6667 to ratio 1. That is for this one. Then you come to this ratio, this other one, the same 4 over 5. You want to put it to ratio 1. So that means you need use this denominator 5 over 5 so that you can get one whole. Then you are supposed to divide both sides by 5. So you will divide this by 5, you will get one whole, that is this. Then if you divide this 4 by 5, you will get 0.8. So the ratio now here is 0.661 to ratio 1, or 0.8 to ratio 1. So you are comparing. So the only thing you compare is the ratios, the numbers, the digits on the left hand side, these ones. So if you look at this one is 0.666. This one is 0.8. So looking at that, 0.8 is bigger than 0.666. So in terms of which one is greater, this one is greater than this. And which one, this represented which ratio? That. So this one also gives us, this answer as greater than this ratio. I don't know whether that one is well understood. Let me check another figure. You are told express the following ratios in the form n to ratio 1. So let me explain more of this so that at least you can get what we mean by that. You are told to express the following ratios as n to ratio 1. So n to ratio 1. Now, if you are given a ratio like, express the following ratios in the form of n to ratio 1 and find out which one is greater. So the first one is 1 to ratio 2 or 3 to ratio 5. So we want to find out these two ratios, which one is greater, but by using this method of n to ratio 1. So starting with the first ratio here, which is 1 to ratio 2. So put it as a fraction. Then I've said you want to make it to ratio 1, and therefore for you to get one whole number here, you will need using this denominator 2 over 2, because 2 over 2 gives you 1 whole. So if you divide both sides by this 2, you will get 1 this side. If you divide this side also by 2, you will get 0.5. So in short, here we have 0.5 to ratio 1. That is for this ratio here. And let us look for this, if we will get, so that we can compare which one is greater. In this case also we have to put them as a fraction 3 over 5. And for us to have 1, we will have to put it to ratio 5 over 5. So that if you multiply both sides by 5, you will get 1. This side, if you divide 3 by 5, you will get 0.6. I think it's 0.6. Because 3 divided by 5, 0.6, so 0.6. So you have 0.6 to ratio 1. So this 2 is what we compare, 0.5 to ratio 1 or 0.6 to ratio 1. So you are told to compare the digits on the left hand side, these ones. So those are what you are comparing to give you which one is greater. So this is 0.5, this one is 0.6. So automatically this one is greater. 0.6 is greater than 0.5. So that means this 3 to ratio 5 is greater than 1 to ratio 2. Let me get another example so that it sinks. So that it sinks and sinks and sinks. We are told to express the following ratios in the form n to ratio 1 and find out which one is greater. So we have 3 to ratio 4 or 5 to ratio 6. Those two ratios, which one is greater? So the same thing, put them as a fraction, then look for, using the denominator, we need, what if we simplify, if we cancel, we are going to get a 1 whole. So that should be 4 over 4. So if you divide both sides by 4, you will get 1. 3 divided by 4, that is 0. That is 6. Is it 6? No, 7, which is 28. Remember 2, 5. So this one gives us 0.75 to ratio 1. Then we come to this side, 5 over 6 to ratio 6 over 6, so that you can get 1. If you divide 5 by 6, you will get 0.6 is the 7 times, which is 40. Is it 7 times or 6 goes there? 8 times. 8 times, which is 48. That is 48. Remainder 2. 20. 3, which is 18. Remainder 2. 3. So this is a recurring decimal. So we will have, this one gives us 0.833. Of course, it is a recurring decimal. So from there to ratio 1. From there we compare. So this is 0.75. This is 0.8. So automatically this one is greater than this. So that means 5 to ratio 6 is greater than 3 to ratio 4. Let me see if there is something else for us. That was comparing ratios. So let me look at dividing quantities in a given ratio. 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 So you have been given some quantities and you are told to divide them in a given ratio. Dividing quantities in a given ratio. So for example, David divide 54 shillings between two learners in the ratio 7 to 11. So this is the amount of money that you are supposed to divide between two learners in the ratio 7 to 11. So there are these two people here. What the first learner is going to get and what the second learner is going to get. So number one, when we are dividing quantities in a ratio form, the first thing we have to get what we call the total ratio. We have to get the total ratio. Total ratio means you add these two numbers. So 7 plus 11, that is 18. So once you have the total ratio, now we can use the total ratio and express those ratios as a fraction. So the first learner, the first person who is going to get ratio 7, so we'll put it over the total ratio 8 times what is supposed to be shared, or 7 over 18 of 54. So that gives us 21, because this one goes there 3 times that, this one is 21. So this one will get 21. The first person will get 21. The second person will talk about the 11, because it had 11 over the total ratio times what is supposed to be shared. So of course this one also goes there 1, 3 times that is 33. So that means that the first person will get 21, the second person will get 33. So the question was asking, you are told to get the total ratio. So you are told to share. So that is how they shared those items. So that means when we are sharing in ratio form, these people are not supposed to get the same amount. That means there is certain things somebody did, one must get more than the other, depending on maybe what they did, or maybe the age, or the price, I don't know. But anytime you are sharing, unless the ratio is the same, if the ratio is the same, they are going to get the same amount. But if you see a different ratio, automatically what they are also going to get must be different. For example, this one is asking, let me get, a loaf of bread has 18 slices. A loaf of bread has 18 slices. So those are the total number of slices we have. So people want to eat bread here. So there is 18 slices. How many people are here? We have somebody here by the name Elsie, Sheldon, and Tabitha. So there are 3 people. So we are going to use each letter to represent one person. So you have Elsie, that is E for Elsie, S for Sheldon, and T for Tabitha. These are the people who want to share these slices. So we want to see who ate more slices than the rest and why. That why you might not answer. So they shared the loaf of bread in the ratio, in that order: Elsie, Sheldon, Tabitha. So in the ratio 2 to ratio 3 to ratio 4. So even looking at the ratio can tell you that these people did not eat the same amount of slices, the same number of slices. So the first thing we do, as usual, we get the total ratio. We add all this. So this one is 9. So if you want to get what each person got, this first person is 2 over the total of what the total number of slices. So 8, 9, 1, 8, 2. So this one ate 4 slices only. That is Elsa. So Elsa, you ate 4 slices. Let me write it on top of you here. Then Sheldon, 3/9 times the total number of slices. So 9, 1, 9, 2. 2 times 3, 6. So this person ate 6 slices. Then Tabitha. Tabitha had 4/9 times 18. 2 times that is 8. So this Tabitha ate 8 slices. So that's how these people ate. So I think this one was according to the ages. Maybe this Elsa was the eldest or the youngest. The person who was distributing the slices decided to use either else Tabitha to get the highest number of slices. So that is how those people shared the bread. Working out ratios. So that one is all about sharing or dividing quantities in a given ratio. What about if you want to work out ratio? Working out ratio. Working out ratio number 1. Working out ratio. Teacher Brenda shared 18 pens among 3 learners. This 18 and something. So the total number of pens here were 18. And these learners were also 3. So the 3 learners are Mwikali. So we have Mwikali. After Mwikali, we have Omolo. And after Molo, we have the last person here called Kantai. So they want to share this thing. Teacher Brenda shared 18 pens among 3 learners. And those are the learners. Now, remember we are working out ratios. This one is not dividing using ratios. We are working out. So the statement continues and says, Mwikali received 6 pens. So this person received 6 pens. So automatically out of 18, 12 are remaining. Let's see what others got. Omolo got 8. Wow. Omolo got 8 pens. So automatically what is remaining here? What is remaining? 4. So this person got 4, you are told. And Kantai got the remaining pens. Question 1. What ratio did the teacher use to share the pens? What ratio did this teacher use to share these pens, which ended up giving Omolo more pens than the rest? So we are going to use the initial of the names. M for Mwikali, O for Molo, and K for Kantai. Then their respective number of pens, the way they got them. Mwikali got 6, so we'll have that. Omolo got 8, and Kantai got 4. So once you have the number of pens like that, then the rule of ratio is ratios are written in their simplest form. So we have to simplify these numbers to the simplest form. So we look for a number that can divide both of them. For example, 2 can divide 4 2 times, 2 can divide 8 4 times, 2 can divide 6 3 times. So once we have this, there is no number that can divide this and this and this. So that becomes the ratio. So this is the ratio this teacher used to share the pens. Ratio 3:4:2. So that is the ratio the teacher used to share the pens. Question B of the same. Kantai later bought 6 more pens. So Kantai, remember Kantai had 4 pens here. So this Kantai is like, he got annoyed and said, how can I have 4 pens? So Kantai later bought 6 more pens. So remember, he had 4. So let us add him 6. So now he's the top. He's now the topmost with 10 pens. 6 more pens. Find the new ratio of pens belonging to Mikali, Omolo, and Kantai. So we are getting the new ratio here. So the same initial, Mikali with his 6, Omolo with his 8, and now Kantai with his 10. So we simplify. 2 goes there 5, 2 goes there 4, and 2 goes there 3. So this is the new ratio, 3 to ratio 4 to ratio 5. That is what we call working out ratios. So you use the quantities given to get the ratio the person used to share those items. Otherwise, still Nick the teacher, continue subscribing, share this information as many as possible. Feel free to comment. Any comment you have, either concern or which area you want us to discuss, we will always be there. Share, subscribe, and like. If possible, put on the notification bell so that anytime I post new content, you will receive the notification. Otherwise, thank you for watching.